This is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. Hey folks, this is Kaushik. I'm sorry my voice sounds like a frog at this point, but I was super excited by this next item from Joshua Bloch's amazing book, Effective Java, that I thought I must release this immediately. So bear with me and my voice because the content in today's point is actually pretty interesting. But before we actually start, I have a quick follow-up point from our last item. Item 5 was avoiding unnecessary object creation. And as I was working on my company's app the other day, I realized another great example of following this technique that I didn't bring up in the last item. This is the technique in Android where if you want to implement an on-click listener, you make the activity implement the listener and then set the on-click listener for your button or clickable view to that activity. This technique actually avoids the extra class load that you have to create by virtue of creating the new on-click listener, and it also avoids like unnecessary object allocation. Now, I'm not saying go back and change every single thing in your program, especially if you have a tool like Butterknife these days. It doesn't even make sense to have this technique, but it just makes the code look a little better, and it's something to think about the next time you actually use on-click listeners. And knowledge is power, so now you know. All right, today's item is eliminate obsolete object references. Now, before you skip this episode thinking, wait, I think I've heard this item already. Let me remind you, the last item was actually a little different. The last item was avoid unnecessary object creation. This one is eliminate obsolete object references. So object creation and object references. Therein lies the difference. Now, the advantages of any garbage collected language is that you don't necessarily have to worry about memory management. The compiler takes care of that for you, which is awesome, except when it doesn't. And you can write code that can get your program into a state where you don't actually allow the compiler to garbage collect your references. And that can be a dangerous state. Joshua opens up with a snippet of code. Now, if you're so curious, you should just pause now, go and look at that snippet and then resume. But I'm going to try and paint you a word picture of that code snippet. Metaphorically speaking. The code snippet basically shows the implementation of a stack. Now, a stack is a data structure that adheres to the principle of last in, first out. And the implementation in this snippet is a very simple object array that stores the elements. We also have an integer that tracks the size of this stack. And as you keep pushing elements onto the stack or popping elements from the stack, we basically increment this integer or decrement respectively. So if you want to add a new entry into the stack, all you do is basically elements of size plus plus is equal to new element being pushed, and similarly element of size minus minus. We just return elements of size minus minus when we pop the element from the stack. Now this program is logically sound. It's completely fine. There are no bugs. If you write tests against this program to test the functionality, in all likelihood you wouldn't run against any problem whatsoever. However, there's a big problem in terms of memory leaking when you look at this program. Now consider this case. What if you had 100,000 objects that you pushed onto the stack consecutively? So you go push all the way to the end. And then you decide for some strange reason that you want to just directly pop all these objects from the stack. So you go pop all the way to 0. Now, given the implementation that we have, you've reduced the size of the object array, but you haven't necessarily removed the references to those objects in your stack. You can see how this could lead to a problem because the object array actually still holds references to these objects. Now, you may think, oh, well, what if it's only a few objects? I mean, eventually they'll get garbage collected, right? It shouldn't be too much of a problem. Well, if those objects happen to be super huge objects like activities that have references to a whole bunch of other objects, then that can be really costly. You only need a few of these before you have like a major catastrophic memory leak in your hands. So how do you go about solving it? It's pretty simple. You just have to dereference the unused objects, or in other words, you just null them out. It's as simple as that. Okay, I know what you're thinking. Well, if the solution is so simple, then why not just go hog wild and always just null out every single object after you're done? Nope, this is wrong and in fact bad practice. Nulling out objects should be the exception rather than the norm. This is Joshua's wise words. It's super critical to follow this because otherwise your code is going to be a complete mess for anyone who has to come and actually read your code. Just imagine if you have a whole bunch of objects and you go about nulling every single one of them after you're done, it can be really messy boilerplate. And it goes against the virtues of having a language that garbage collects after itself. Okay, so what is the right thing to do? Well, the right thing to do is actually define your variable in the narrowest possible scope. So if you have an object used only inside a method or maybe an if loop, then that is the right thing to do, because then the reference to that variable naturally gets eliminated as it falls out of scope. Don't worry too much about this point. Just think of it as a good virtue, because we have a whole item in the future devoted just to this technique. Okay, so wouldn't it just be easier to have like a rule of thumb to know when you really have to worry about these things and when you don't? And that's exactly what Joshua gives us. So the first rule, he says, is whenever a class manages its own memory, you have to be alert for memory leaks. So in the case of this stack implementation, for example, we kind of are managing our own memory because of that internal object array that we had. So you can see this rule immediately applies to that situation. So whenever you have an object that you have written that tends to manage memory or references of other objects, then you should be hyper alert for this problem. Another similar situation, caches. A cache is where we basically want to reuse the objects, and so we hold on to them for a period longer than their natural cycle or longer than what the program alone understands. So if you're ever implementing your own cache, then again, be very aware that there is a high possibility that you have memory pressure or memory leaking because you don't deregister the objects properly. And the last common source of memory leaks, the third one, is listeners and other callbacks. This, dear listeners, is basically the bane of us Android developers. Now, we have talked about this on numerous occasions before, so I'll just try to echo the points that Joshua makes in the books, which is very similar. If you implement an API where clients register callbacks and you don't deregister them explicitly, they tend to accumulate. And unless you take some action, these accumulated listeners or callbacks would lead to memory leaks or memory pressure. Joshua also says that the best way to ensure that callbacks are garbage collected or GC'd promptly is to store weak references to them. And if you read that famous article that we have always pointed to and everyone points to about leaking inner classes and handlers on the Android Design Patterns blog, if I remember right. That's basically exactly what they suggest. Okay, so all in all, extremely important item. You've probably run into this situation at some point in your Android development career. Joshua winds this point down by saying, since memory leaks become obvious only when they've reached a catastrophic point, it helps to be constantly aware and maybe watch out for this kind of stuff. So that's basically the item. I have a couple of closing points that I wanted to make that I thought would be interesting. In the book, Joshua mentions that click listeners could lead to memory leaks. So do all click listeners lead to memory leaks? No, because when you actually set a non-click listener, the Android framework takes care of deregistering those click listeners for you. Because they're all scoped only within the life of your activity, when your activity goes away, all those registered on-click listeners and views also go with it. That being said, however, if you are registering the click listener with anything other than all this view-related stuff, then you probably have a problem on your hand. Unless, again, of course, you're explicitly dereferencing that click listener again. Now, those are click listeners. Handler objects, on the other hand, are a different beast. If you have a handler as an anonymous inner class with a strong reference to your enclosing activity, then in all likelihood, that is going to be a leak because its life cycle is controlled by this thing called a looper object. So it's not really the same situation as the on-click listener. Again, the very famous article on Android design patterns, I'll add a link to that again in the show notes. They go into great detail as to how this is caused and how you can avoid it. And he also suggests the weak reference technique that Joshua makes in this book. Another point I want to say is it's important to know why the things tend to leak, sure. But if you're an Android developer today and worried about this kind of stuff, just install Square's leak canary and be on your merry way. The theory is important when you want to remove the leak, though. So it's good to know the theory, but identifying these memory leaks are usually the biggest problems. They're very hard to find, and that has been made super easy by Leak Canary. Leak Canary, thumbs up. All right, one more point. If you use Butterknife, as 50% of the whole Android world does, you should watch out when you use Butterknife in fragments. Now, if you read the documentation carefully, if you're using Butterknife in fragments, you have to make sure you unbind, or what was previously called reset, I think. If you don't do that and you have Square's Leak Canary installed, you'll notice that there's actually leak in fragments. They go into the details in the documentation, so I'm not going to do that right now, but I just thought it was interesting because many people don't realize that unlike in the activities for fragments, you have to explicitly call this unbind method. All right, in the end, I just want to summarize the highlights from this item. Always be aware of obsolete references in your program that could leak memory, and this usually happens in 3 places. A, programs that manage their own memory, so like the stack or the queue implementation that we talked about earlier. 2, caches. So caches, by virtue of what they are, can tend to lead to memory leak or memory pressure. Watch out for those. And finally, listeners and callbacks. Thank you for listening, and thank you for bearing my frog voice for the day. I hope you found this item interesting and useful, and catch you in the next episode.